So in this story here, we have a game. We have two spinners, people spin, and therefore they collect the tokens that are associated with the numbers. So we understand with spinner A, your arrow lands here, you get 6 tokens. That's the idea. Okay, so in this part, spinner B is spun a large number of times, so loads of times. Find the expected average number of tokens that the player will collect each time. Now, what's tricky here was that they didn't mention expected value, but they say expected, and that was part of our question. That was the bold part of our sentence. So what they are referring to is the calculation of expected value. It's just here we are saying expected average number, but it is the same thing. Now, how do we calculate that? We multiply probability by associated either euro with it or the number, isn't it? Plus, and again, probability multiplied by either euro assigned to it or a number. Here we have number of tokens. So first, let's identify for our spinner the probability of each. So let's start from the lowest value. So for 0, how do I calculate the probability for them? So let's not forget, on top of the fraction, our event, on the bottom of the fraction, all events. In this case, what are all events? All possible landing. I have 6 of them. What my event? I'm looking for 0. There is 2 of them. So that means 2 over 6. For 1, then the probability will be what? Again, all possible doesn't change, but my event is only 1. For then the next value is 3. Again, the bottom part will be the same. How many? 3 can I get as well? Only 1. Then we have 4. And again, at the bottom we have 6, and only 1 of 4 can happen, and 8 is exactly the same 1 out of 6. So now that we assign probability to each number, we can calculate expected value. So 0 multiplied by 2 over 6 plus 1 multiplied by 1 over 6 plus 3 multiplied by 1 over 6 plus 4 multiplied by 1 over 6 plus 8 multiplied by 1 over 6. And all we have to do, put it all of that in the calculator, press equal, and we get that is 16.6, which is about 2.67 if we were to round it up. However, here we don't have terms and condition. I will encourage you to just leave it as a fraction. Then in the next part, Jill is playing a board game that uses both spinners. She has calculated that expected average number of tokens for one spinner of spinner A is 3. Now, again, in the context of this question, what that expected value means is that if we keep on spinning, okay, a large number of times. So here, with spinner A, we understand we will most likely get 3 tokens on average over a long time. Sometimes we get 6, sometimes 0, sometimes 4, but overall we're going to get 3. We've done before our calculation for just now for the B spinner, and we understand that is about 2.67. Okay, so we get that. So what are the options here? So at certain point in the game, she can choose one of the 3 options below. She can either play what? Pay 2 tokens, so there is cost, and play spinner A, or pay 2 tokens and play spinner B, or don't spin either. So therefore, Jill decides that she will choose one option at the beginning of the game, and she will always use that option in the game. What's the idea of the game? To get the biggest number of tokens, isn't it? That's the point. Based on the expected average number of tokens for one spin of each spinner, which option would you advise Jill to choose? So that's what I'm saying. If you're playing the game, you're gathering the token, what you want, the chance of getting the most amount of token. So you can see that with A, you're going to be getting on average 3 tokens. I know you are paying 2, but you are getting 3 on average. With B, you are getting 2.67, so it is less. So definitely it's better to constantly use option A, because that will give me on average, the bigger chance of winning more tokens. That's the idea. And as you can see, it seems deceiving if we don't do calculation, because without the calculation, you are thinking, well, B has 4 and 8 even. A doesn't have 8. However, A will give you a better number of tokens that you can win than B.